Thank you for your time and the opportunity to share our research activity. So my name is Shiku Hirai from NTT R&D. I belong to the Research and Development Department of NTT Holdings, and our mission is to conduct basic research, provide research outcomes to business companies like NTT Docomo, and support their commercial introduction. And this diagram shows the mobile coordinate function architectures. UPF means user brain functions, which is responsible for accommodating user sessions behind the radio base stations and forwarding users' packet data to the appropriate destinations like internet or other networks. So 5GC includes other control plane functions for users' mobility management and session management. The 5GC on AWS project is being promoted by the NTT Docomo, which means 5G core network functions, except for UPF, are deployed on AWS regions. And as you may know, computing platforms will become more decentralized toward beyond 5G and 6G, and various functions and services will be deployed at far edge, a site located physically closer to the user devices than current edge cloud design pattern. And in this far edge, efficient use of those computing and networking resources is one of the most important requirements for telecom operators. So we consider NVIDIA's DPU and GPU can be controlled as in-network computing infrastructure in this far edge. And UPF will be the key functions to link mobile and service domains in far edge, as shown in this diagram. So we think it should be lightweight, high performance, energy efficient, and reliable. So we have implemented the DUPF using NVIDIA's Bluefield-3 card. Okay, so this is the detail of our DUPF architecture on Bluefield-3. UPF agent is a container running on Bluefield's ARM core. It is responsible for the data plane session control cooperating with the control plane functions of 5GC. For the data plane session control, we are using mainly Docker Flow APIs, and main tasks required for UPF such as GTP encapsulation or decapsulation and QoS processing are processed Connect X7 e-switch integrated into Bluefield-3 DPU. And our DUPF can be combined with some value-added functions required for in the telecom networks, like DPI. And this shows the results of our simple QoS verification results for bandwidth guaranteed users. We are using 200 gigabit Ethernet UART ports Bluefield-3 card. In this case, our DUPF is fully offloaded into Bluefield-3. And you can see that the QoS functionality unique to telecom networks is realized on Bluefield-3 card. Also, the latency and power consumption were also tested. So this is compared with and without offloading into Bluefield-3 DPU. BUPF has no UPF stack offloaded into the NIC and uses the host CPU cores. On the other hand, our DUPF is fully offloaded into Bluefield-3. So you can see the significant reduction in end-to-end 95% tail latency. In this case, BUPF did not use the DP decay. So the interruptions by the OS were a major factor for the delay increase. But the UPF has no such effect. Also, regarding the power consumption, you can see 13% reduction. In this case, BUPF used the DP decay. So the allocated host CPU cores were locked at 100% usage, and the power consumption increased because of the polling processing required to bypass the Linux kernel stack. And DUPF is low power consumption because it is fully offloaded into the Connect X7E switch. We expect this effect to be more enhanced when the more DPU card is in the same server system. Okay, next, so we have started the collaboration with Docomo guys to challenge interconnecting DUPF and Docomo's 5GC on AWS. In DUPF, more complex protocol processing for linking with 5GC was required than before because the connection destinations is the same software as the Docomo's commercial 5GC. Although we are not able to support all of Docomo's specifications, but we are able to support the basic sequence such as registration and establishment of user sessions. Okay, in addition to simply connecting to Docomo's 5GC, we also conducted large-scale testing to see if our DUPF could meet carrier-grade performance. The detailed results are as shown in this table. Okay, finally, so I'm so excited to announce our collaborations with F5. Yeah, we plan to work with F5 to carry out a POC for AI local breakout use case. In response to the recent rise in interference services using generative AI and the deployment of edge AI. As part of this, we will support N9 is the interface between two UPF. One is the distributed UPF on edge side, and the CUPF on the central data centers. Yeah, so as our and we can leverage F5 expertise in 5G volume Kubernetes delivery and security to this far-edge use case. And we think F5's Peak IP Next for Kubernetes on Bluefield-3 provides various added values to the telecom networks in terms of this AI LBO use case, GPU resource optimization, efficient AI pre-processing, and multi-tenancy, and so on. Yeah, so as our collaboration has only just started, we plan to continue to deepen our collaborations in the future. Yeah, that's all. Thank you.